Hello and welcome everybody. Today we're going to look at Perception Fleet, GE's Advanced Transformer Fleet Management application. My name is Byrne. I'm the Product Manager for Software and Application Solutions in Monitoring Diagnostics, which is a division of GE Digital Energy. I joined GE in 2010 as a Software Quality Manager, and last year I moved into the Subject Matter Expert role where I looked after software applications, and more recently I changed into Product Management, where it's my responsibility to look after and drive the direction of the Perception application. What we're going to do today is look at three main aspects of the Perception Fleet product: the benefits, the analysis, and the visualization. For the benefits, we're going to look at how Perception Fleet benefits individuals who use the application day to day, as well as the organization as a whole, and how it can help you make critical business decisions. So let's take a look at some of the challenges faced in the industry today. Monitors and sensors by their very nature produce a large amount of data. That data must be manually interpreted and understood, and that takes considerable resource within an organization. Something else that is affecting our customers at the minute is the tightening of their operating budgets, which forces them to do more with less as the assets continue to increase as new customers continue to come online. The next problem that we have within the industry is the retirement of expertise. So we're hearing from our customers that a lot of their transformer experts are coming to the age of retirement, and they have no apprentices in the background to take up the mantle and perform the critical task of understanding and interpreting the data and the transformer's condition. This is forcing organizations to rely heavily on tools and software to fill this knowledge gap. Now we're going to take a look at how Perception Fleet directly impacts your organization, specifically focusing on the financial benefits in terms of CapEx and OpEx investment, system optimization in terms of engaging experts and the ease of customization, and finally reliability enhancements in terms of the costs of an outage and focusing on what matters. First, let's take a look at the financial benefits, specifically the CapEx investment. Without the right data, it can be challenging to determine how to allocate a limited capital budget. Which transformer needs to be replaced first? Is a unit at risk of failure and should be replaced immediately? Where can the capital investment make the biggest impact? Perception Fleet solves this challenge by calculating a risk index for each transformer in the fleet using dissolved gases and pushing analysis. Based on international standards and committees, as well as GE technical knowledge, the risk index categorizes a transformer's condition and provides a clear indication of which transformers in the fleet should be replaced and where the capital investment will have the greatest impact. So the next area that we're going to look at is the OpEx investment. Gathering, analyzing, and applying transformer data across an entire fleet can be extremely costly and time-consuming. Understanding which transformers need attention requires specialized transformer experts to often travel hundreds of miles to each location and manually collect the data for analysis, heavily impacting on a utility's operating expenses. The risk dashboard in Perception Fleet provides a concise list of critical fleet information, including diagnostics. The dashboard automatically updates when a risk assessment is performed, and utilities are empowered to move to condition-based rather than scheduled maintenance, with informed crews assigned to the most critical transformers in the fleet, ensuring materials are utilized where they are needed most. So next we're going to move into the system optimization area, specifically looking at engaging our experts. Transformers are highly complex and require a high level of expertise to accurately assess complex conditions and determine the best course of action. In addition, faults can appear and escalate to critical levels very rapidly. Getting the right information into the right hands at the right time is crucial to minimizing downtime. Perception Fleet provides analysis notifications to engage experts when the need arises. When an alarm is triggered, a notification containing a snapshot of critical transformer data is automatically sent to designated experts. This allows the experts to remotely analyze the data and recommend a course of action to prevent any failures. So now we're going to look at the ease of customization within Perception Fleet. Each transformer has unique operational and chemical characteristics, Transformers sometimes function outside the normal analysis standards, which makes them difficult to assess using established standards. For such transformers, operators need to customize standard risk assessment rules to specific needs and best practices of business requirements. Perception Fleet's Workflow Designer allows operators to create custom workflows and assessments to suit their needs. This flexible and powerful feature enables custom ranking rules based on businesses' own best practices and unique characteristics of their transformer fleet. Now within the reliability enhancements, we're going to take a look at the costs of an outage. So utilities face penalties and fines for prolonged outage events. Transformer failures typically lead to long-term outages. So in addition to loss of revenue and equipment costs, system reliability also carries heavy penalties and damage to utility reputations. Perception Fleet ranks transformers using a risk score element that considers its level of impact on the system. Similarly ranked transformers are grouped together and then further ranked according to their potential risk. This feature helps highlight the highest risk transformers and can be used to justify decisions on investments and reliability. Next, we're going to take a look at focusing on what matters. Transformer monitoring devices generate a significant amount of data. To analyze and interpret this data takes time and a high level of transformer technical knowledge to ensure critical issues are detected. Perception Fleet's risk dashboards and risk indexes help focus the utility on the assets that require attention. The algorithms analyze dissolved gas concentrations and utilize techniques such as piecewise linear approximation to determine gas level rate of change. Perception Fleet automatically performs in-depth transformer analysis, helping to ensure critical factors are not overlooked. Next, let's take a look at the analytics performed in Perception and how it evaluates and interprets the data received. Within Perception Fleet, when data is received from the monitor, our intelligent algorithms evaluate the data and assign a risk index to the transformer. You can see the categorization in the left-hand table. We have a risk index of 1, which indicates that the transformer is in good condition. 2 shows that there are minor defects not affecting reliability. 3 shows defects that may affect future reliability. 4 indicates that there are serious defects that may have serious consequences. And 5 shows that the asset has dangerous defects that may cause faults. As you can see from this table, we also color code the asset to make it easy to identify which category the transformer is in. On the right hand side, you can also see a representation of our fleet ranking table. Once the transformer is assigned a risk index, it is then shown in the fleet ranking based on its risk of failure. As you can see at the top of the table, we show assets that are most in danger of failing, right through to the bottom where the assets are seen to be operating as normal. Whenever we evaluate transformer information, we look at these specific areas. We look at the main tank, which accounts for 30% of failures, the tap changer, which accounts for 35% of failures, bushing failures, which accounts for 15% of failures in the transformer, and cooling system failures, which accounts for 5% failures in the transformer. Within Perception, we specifically look at DGA concentrations and rate of change, bushing capacitance, power factor and partial discharge alarms, nameplate data, and transformer criticality information. The first algorithm we're going to look at is the standard DGA algorithm, which is based on DGA and moisture absolute concentration analysis. The rules that are built in the algorithm are taken directly from the IEEE C57104 and IEC 60422 standards. You can see the different gases in the table and how their risk indexes may be applied. So for example, for hydrogen can reach a risk index of 5 because it's seen as being a critical fault gas, whereas carbon dioxide is considered not to be a serious indicator of a fault, so it can only reach a risk index of 3. And that means that no matter what the levels of carbon dioxide are within the transformer, it will never push that asset into anything higher than a risk index of 3. Whereas if there are high levels of hydrogen, or even acetylene, for example, in the transformer, that transformer can reach a risk index of 5. So whenever the online monitor takes a sample from the main tank, data filtration is applied on that data. And that's to ensure that no spurious information is passed through into the algorithm. So our analytics and our intelligent analytics engine removes what it regards as spurious data. So that could be data, for example, if there's a spike in hydrogen and the next reading of hydrogen does not show the same level of hydrogen gas, then the initial spike will be ignored for purpose of the evaluation. So you can see in this example here, whenever the multi-gas monitor takes a sample from the main tank and performs an evaluation on the asset itself. So we can see that acetylene has reached a risk index of 4, and that is purely because of the levels of acetylene that are detected within the main tank. So that asset is then considered to be at a risk index of 4. Another thing that we look at within the DGA algorithm is the gas rate of change, and that is in comparison to IEC 60599, which specifies the gas rate of change in an expected normally operating transformer. So again, you can see the different types of rate of change and what risk index they can indicate. So we look at 3 different time spans within the asset. We look at a long rate of change, we look at mid rate of change, and then we look at short rate of change. And you can see for hydrogen, ethylene and acetylene, we look at short rate of change, and the short rate of change can push the asset into a risk index of 5, whereas for carbon dioxide, carbon monoxide, methane and ethane, the highest risk index that they can reach is a mid rate of change, pushing the asset into a risk index of 4. So again, as the online monitor takes a sample from the main tank, it looks at the long rate of change and it performs the long rate of change calculation within the perception algorithm. Again, the data is then filtered to ensure that we don't have any spurious information, and the measurements are then taken and applied within the algorithm. We perform the same calculation for the mid rate of change and then also for the short rate of change to establish which rate of change is considered to be the worst for that asset. So you can see that acetylene has pushed this particular asset into a risk index of 5. So you can see 5 is the categorization that it's given. Here you can see exactly what we look at in terms of what we call the piecewise linear approximation rate of change. So we look at the 3 different time spans. The long rate of change shows observations of defects developing and accumulating through the transformer's life. So that can be seen as overheating defects, aging, and sometimes with discharge activity, and is generally related to the natural aging of an asset. The mid rate of change are observations that can be down to seasonal variation, where you have high levels of electrical load on an asset over a period of time, which changes over the year. That can also be mid rate of change can also be attributed to ambient condition changes, so the natural operating of the asset in winter compared to in summer. And then our short rate of change is observations of defects which have spurious rise and need to be tracked at a short time, and these are the ones that are seen to be the critical. So they show discharges of high energy, high temperature overheating, and generally any kind of increase that is detected over a short period of time needs to be investigated immediately. Once all this information is taken in and calculated, a final risk evaluation is given to the asset for the standard DGA algorithm. Another thing that we've done with our DGA algorithm, as well as looking at the IEEE and IEC standards, is we have taken in some C-grade TB227 best practice techniques. So the technical bulletin CB227 provides 5 transformer conditions in terms of reliable operation. And what we've done is we've taken these best practice techniques and we've applied them into our algorithms to add more in-depth evaluation of the asset. This table shows which assets are supported within the algorithm and analytics engine in perception. In our previous incarnations of Perception Fleet, we only supported the transfix and multitrans products. Now we also support the TapTrans, Minitrans, Hydran N2 and the Hydran 201 Ti. We've also updated our IEC 60422 evaluation for moisture to take into consideration the changes made in the 2013 edition. Next, we're going to take a look at our bushing algorithm. The bushing algorithm is based on the alarm limits configured within the BMT300 device for power factor capacitance, partial discharge count, partial discharge index, and partial discharge average apparent power. When we look at these particular measurements within the bushing monitor, what we're checking for is we're checking to see if any of the measurements that are taken are close to the alarm limits that are set. So whenever the BMT takes a new measurement, we compare the measurement to the alarm levels that are set within the bushing monitor, and we then look at the risk index effect based on those measurements. So you can see from the table we have here, we have capacitance, which is measuring at 2%, with our caution high alarm set to 5%, and our alert high alarm set to 10%. So the risk effect on that particular measurement is 40%. So it's seen to be in a risk index of 1. Whereas our partial discharge average apparent charge, the measurement was taken was 1000. The caution high alarm is set as 1000 and the alert is set at 2000. So that means for that measurement the bushing monitor is showing a risk index of 4. So the risk index of 4 is then applied to that particular asset for bushing monitoring. One of our new algorithms that we've introduced with our latest version is the new Simplified DGA Algorithm, and it works on the alarms that are set within the online monitor and not information taken from standards and best practices. So you can see in this table exactly how we look at the measurements and the alarms within the particular device. So for example, hydrogen, risk index 5 for hydrogen is the high or alert alarm that's set in the device. Risk index of 3 is the warning, caution or high alarm that is set in the unit, and then your risk index of 1 indicates the asset is not in any alarm state. So we look at that for all the gases as well as the total dissolved combustible gas, ratios of CO2 against CO, and also moisture content. So whenever a sample is taken from the device, if an alarm is triggered, so you can see an example on the screen, carbon monoxide has triggered a high alarm. The device is then given the risk index associated with that alarm. So for this example, it's risk index of 4. Another new algorithm we've introduced is our standard OLTC algorithm, and that looks at resistor type dissolved gas analysis of tap changer diverter using gas ratios taken from EPRI. So you can see the ratios on the right hand side of the screen, and you can see the table on the left hand side that shows the effect on the risk index for that asset. So you can see for FR and R1, the highest risk index that the asset can achieve is risk index of 3, whereas for R2, R3 and moisture, it can achieve a risk index of 4. So whenever the diverter tank is sampled, again, we filter the data to take out any spurious results, and then we perform a calculation based on the ratio information taken from EPRI. A risk index is then applied for each of the ratios, and we then take the worst risk index for each of the ratios, and that is the categorization that's applied for that asset. So you can see we have a risk index of 4 for this particular algorithm. We also have the same we also have the standard OLTC algorithm in terms of rate of change of gases. So not only do we look at the ratio for concentration, we also look at the gas rate of change. So you can see it follows the same principle as the standard DGA algorithm for rate of change. So we look at the ratios again, the 4 ratios and moisture. We perform a long rate of change calculation for the ratio. We perform the mid rate of change calculation, and then we perform a short rate of change calculation. And the same principle applies. So the one is seen to be in the worst condition, for example, for this example, it's risk index of 4 for moisture content within the particular asset. We also have a simplified OLTC algorithm, and again it's based on alarm breaches for DGA and moisture. So we look at the alarm levels that are set within the tap trans for the diverter tank, and then we can apply a risk index for those particular measurements, determining what the risk index is for the asset when an alarm is triggered. So you can see the diverter tank sample is taken. If an alarm is triggered, so for an example in this particular screenshot you can see that hydrogen has triggered a high alarm, then a risk index of 4 is applied to that asset. One of the critical factors whenever evaluating a transformer is understanding the transformer's criticality. Within Perception Fleet, we're able to capture the transformer criticality information, as you can see on your screen now. We look at certain areas such as the power delivery loss percentage, PCB level, access for minor repair, access for major repair, strategic spares, as well as a host of other information that helps us evaluate the criticality of the transformer. All this information is taken into account whenever the risk index is calculated for the transformer. So for example, if an asset is close to public and access for major repair is major rebuild, then that directly impacts the risk index categorization for that asset because it is seen as being at higher risk and a higher criticality. So a transformer with similar measurement characteristics as this particular asset will have a lower risk index because this asset is more critical in terms of the information fed into perception. The final risk index for the assets then is calculated for each individual algorithm. So a transformer or an asset within perception can have multiple algorithms assigned to it. Those algorithms are then ran through the analytics engine to come up with a separate risk index for each of the algorithms. But in order to have a simple final risk score for the asset, we take all that information, we run it through the analytics engine, we look at the criticality details for the asset, and then we come up with a final risk score. So you can see in this example, we have 2 of our algorithms are producing a risk index of 4. We have one that has a risk index of 5. And when we run the data through the engine and take into consideration the criticality data, we come up with a final risk index of 5. Something else that we apply to the asset is a risk score. And the risk score allows us to categorize the asset within the fleet tree. So you can see, for example, we have 2 assets in this table that are in category 5, which is indicated by the red. But which of those assets is in the worst condition? If you have multiple assets all falling within the same risk index, how do you know which one is the most important and the one that needs to be looked at first? And that's why we calculate the risk score. So the risk score is calculated by taking all the results from the algorithms for the assets, we run them through the analytics engine, and we come back with a risk score. If any new analytics are applied to those assets, so for example, if you add a bushing monitor onto the transformer as well as the DGA monitor, then they will also have their own separate risk score, but that will directly impact the final risk score of the asset, so it will adjust the risk score. So you can see the example here on screen. So we're always aware of which asset is considered to be at highest risk. So here we can see an example of how that would look in perception. So we have an asset that's measured over time, and you can see as gases start to increase, its risk index changes and it travels up the ranking table within perception. So you can see right up until the acetylene levels push the asset into a risk index of 5. You can see in the right hand side the dashboards where we output this information in perception, and we'll look at that in a little more detail later in the presentation. But we've tried to make those dashboards as simple and as easy to follow as possible, so you can identify exactly what's happening to the asset and what condition the asset is in, as well as how your entire fleet is performing. Perception also comes with a workflow designer application, which is bundled along with the Perception Fleet software. The workflow designer allows you to create your own custom algorithms or modify the algorithms that we send out with Perception. So if you have assets within your fleet that fall outside of the norm in terms of gas levels and ratio information and moisture, you can feed that information directly into the workflow designer and manipulate the algorithms that were provided by GE. If you would like to create your own algorithms from scratch, that's also possible as well using the workflow designer. The workflow designer is based on Microsoft Workflow Designer, which is an incredibly powerful analytics tool. You can design extremely complex algorithms or extremely simple algorithms based on your own company's best practices and needs. When creating your own algorithms within Perception, you can use any data that is captured in Perception. So any data that can be captured in terms of online monitors or through importing data from another application or importing CSV file information, all of that data can be used when creating your own intelligent algorithms. GE also offers a pay-for algorithm design service, where we will write algorithms that are specifically designed for your organization's best practices and the unique characteristics of your transformer fleet. Let's take a look at how Perception visualizes the information once it's received from the device and run through our calculation engine and workflow algorithms. Perception has built-in dashboards, which are designed to provide simplified and concise summary of the individual assets as well as a fleet overview. The data is displayed in a single page, providing users with concise information with minimum page interaction. Each transformer's dashboard worksheet displays critical data and ranking history. A fleet summary dashboard also provides critical information about the entire fleet. So I'm just going to bring up the Perception application to show you how it looks. Here you can see the fleet overview dashboard. So you can see the top, the information in the header shows the total number of transformers in the fleet, how many of those transformers are currently being evaluated, so 16 for this example, the current average fleet risk index, which is 2.6, any alarms that are raised within the fleet, and any devices of the online devices that are currently experiencing a service alarm. You can see in the body of the dashboard we have our risk index distribution of fleet represented in a pie chart, and that shows you the distribution of the different risk indexes within the entire fleet and how much of your fleet is in a particular risk category. So you can see for the risk index of 5, we have 2 assets that are in that risk index, and that represents 9% of the fleet. For risk index of 4, we have 1, and that represents 4%. And you can see how it breaks down for the rest of the risk indexes here. This white section indicates any assets which are not being evaluated. So that's currently 7 assets, and that's 30% of the fleet. And that could either be because the user or the organization has chosen not to evaluate those transformers, or there is no measurement information to evaluate for those assets. Under the latest events section, we display every event that has been captured by Perception, but whether that's shifting of assets within the fleet ranking table, a change in risk index for an asset, if an asset triggers an alarm, so if a multi-gas monitor, for example, experiences a high alarm, if it experiences a service alarm, if for whatever reason you're unable to communicate with the online monitor, any event that's captured in Perception is output to this single display, and it means it's very easy to see exactly what's happening within the fleet without having to drill down into the asset tree to look at individual items. The top critical transformer list on the right hand side here shows the assets which are considered to be at highest risk. So they're any assets that are in red, orange or yellow risk index, so risk index 3, 4 or 5. And they're the ones that need to be specific, that need specific attention. So they're the ones that you should be considering whenever you generate your condition-based maintenance program. They're the ones that really need critical attention. At the bottom then we have the history of our average fleet risk index. So you can see in this example we had a risk index of 2.4 at the start, and it's now up to 2.6. And what this history shows you is it shows you if your planned maintenance or your scheduled maintenance tasks are effective. So are they actually addressing the problem within your fleet? Is your fleet getting healthier or is it getting worse? If you see your average risk index increasing, it means that you're not addressing the critical assets within the fleet, or you're not performing the specific maintenance tasks that are required to reduce the risk index. You still have assets within your fleet that are going into a fault spiral, and it is causing your average risk index to increase. Ideally, you'd want to see the risk index remaining level or decreasing as you implement your maintenance plans and start repairing your at-risk assets. Just quickly want to show on the left hand side how the ranking table looks. So you can see here the ranking table on the left, and you can see as I hover my mouse over the different transformers, the risk score pops up to show you what the risk score is for that asset, as I explained earlier in the presentation what the risk score is used for. You can see here on the screen now I have my device summary dashboard, and the device summary dashboard captures all the critical measurement information that is taken from the transformer. So for this particular example we have a bushing monitor in the form of an Intellex BMT300. We have a DGA monitor, which is our multi-gas Kelvin product, and we have an MO150 as well. So our bushing monitor section shows us the power factor and capacitance changes that are being experienced within the actual unit, as well as the partial discharge index. This is the most recent measurement that is taken from the device, which is displayed in this dashboard. Within the DGA section then we have the latest dissolved gas measurement, and you can see we color code the gauges as well to show if any of the measurements have breached an alarm. And then finally we have our MO150 section, which shows additional information such as top oil temperature, bottom oil temperature, winding hotspot HV temperature, and winding hotspot TV temperature. So any additional information that's captured by the MO150 or the Hydran M2 with models that's seen as being critical is output to this section as well. Just as well at the bottom of the DGA section you'll see that we have a small TDCG graph. This is our total dissolved combustible gases chart, and it just gives you a snapshot of the gases within the asset over a period of time to show you if your gases are increasing or falling over time. Within the header of the transformer dashboard then, you can see we have the transformer information, so we have the name, the serial number, and the rated voltage information of the asset. We have our risk index circle, which shows you the risk index journey of the asset over a 9-month period. So you can see 9 months ago this asset was in good condition, it was a risk index of 1, and then over time a fault started to occur and the risk evaluation changed and it went up. So you can see it went to risk index of 2, then the issue seemed to correct and went back to risk index of 1, but then the fault spiral continued until the asset is now in its final risk index, which is risk index of 5. This asset is the worst asset of a fleet of 23. It has no service alarms, but it does have a concentration alarm. You can see its current load and its load PU percentage, and you can also see the ambient environment information for this asset also. Our other unique transformer dashboard is our ranking graph history dashboard, which shows you the history of the asset over time in terms of its risk evaluation and its ranking. So where the top circle risk index showed you a 9-month snapshot of the asset's journey, the risk index chart shows you a 30-day evaluation, and it also gives you more detail. So you can see 30 days ago this asset was in risk index of yellow, and now it's in risk index of red, risk index 5. If I hover the mouse over the point, it will show you why it's considered to be a risk index of 5. You can see for this latest measurement point that it's saying that there's no data, and that's because there's been no data that's been taken from the online monitor for a day. So we still apply a risk index of 5 because that was the last known condition of the asset, but we let the end user know that this is not a new calculation, this is a historical risk index. If I go to the one prior, you can see on the 24th of November, a risk index of 5 was calculated, and you can see the reason for that calculation. So for example, we have an absolute hydrogen concentration of 811 ppm, and this may affect short-term liability. Then we have a C2H4 concentration of 148 and an acetylene C2H2 concentration of 49. And you can see also we have alerts that have been raised based on the rate of change for these particular gases as well in this asset. So this table is particularly useful in seeing, or this graph, sorry, is particularly useful in seeing exactly how this asset is performing over time. So if it's an asset that's continuing to get worse, and its condition is getting worse, then you can see how quick or how rapidly its condition is deteriorating, and the reason for that calculation, the reason for the deterioration as well. So I'm just going to go back to the presentation. So one of our new features that we recently introduced in Perception is our Perception Web interface, and that's an interface into the Perception Fleet application using any modern browser application. So if I just bring up my web browser, so you can see here I have a web browser running, and I'm just going to log into the Perception Fleet application. So you can see I'm presented with the same dashboard that we were looking at a minute ago in the Perception desktop application. So we have our same fleet overview, we have the total number of assets within the fleet, we have our risk index distribution pie chart, we have our ranking table showing the assets that are and how they are ranked, we have our latest events, and then below we have our average fleet risk index. I can also click on this arrow here and it will show me the asset tree. If I click on the asset tree, so if I drop down, you can see these are all the substations and then the subsequent transformers under the substations within my particular Perception Fleet asset hierarchy. If I click on this GE distribution area, it'll pop open the wallboard that I have configured for the Perception Fleet application. So you can see the wallboard is a virtual representation of your asset fleet. So you can apply any image as your wallboard image, whether it's an aerial screenshot or an image that's taken from an online map service. You can apply that in Perception, and you can see you can then drag your particular dots to the geographic location within the image. Anytime an asset generates an alarm, the node within the wallboard, as you can see at the bottom here for our GenTran 116, will change to show that there's an alarm for that asset. So it's red because there's an alarm underneath one of the transformers within that substation. The other assets are performing well, so you can see all the other nodes are green. I can then drill down into the substation, so I can drill down into a further wallboard that shows a closer view of the substation. And you can see I have 3 transformers being monitored. 2 of them are operating as expected, and one of them is over here has an alarm. So again, I can drop down to that particular transformer and I can see another wallboard showing exactly what's happening within that asset and where the alarms are coming from. So the alarm is coming from my multi-gas product, as you can see here. As per the Perception desktop application, I also have the dashboard for the fleet dashboard showing the most critical data. So you can see we have our bushing information, we have our dissolved gas concentration taken from our multi-gas product, and then we have our MO150 information, so you can see here as well. and this is all accessible through any modern web browser. It can be viewed on a laptop, notebook, a tablet computer, or on a smartphone, and the screen will dynamically adapt based on the screen size. As you can see here, as I move in, so if I was to create my browser to look like a smartphone aspect, you can see how the data then flows and rescales and shifts so that it is suitable for that particular view. If I was to go back to my home screen, the same will happen again. So you can see how it automatically adjusts for the particular screen size for the device you're viewing it on. So if you're viewing this on a smartphone, it would automatically adjust to that particular view. So the wallboard we already had a look at, so we looked at the different aspects of the wallboard, and this is just going through some of the other critical information. So we call it what we call a traffic light system. So again, it's all about at-a-glance notification, so understanding how your assets are performing. Are there any alarms raised on the assets? And you can see that instantly by seeing the changes in the node colors on the wallboard. Perception Fleet also still contains its inbuilt diagnostics. So it has a suite of diagnostic tools built right into the application, ranging from Duval's triangles, classic LTC type 4 and type 5, Rogers and Juniper's ratios, key gas analysis with statistical matching, 3D gas ratios using IEC 60599 and IEEE C57104, a total dissolved combustible gas chart, and Japanese ETRA. So they're all built right into Perception. Let me just bring up Perception and show you here. So if I go to my asset, I'm just going to bring up, this is my Asset Explorer. As you've seen in the web browser, it's exactly the same format and layout as in the desktop application. If I click on my multigas product and then click on my Duval's triangle, so you can see my Duval's triangle here, and you can see the measurement points that are plotted out in the Duval's triangle. Then we have our Japanese ETRA, our ratios. So one of the other features in Perception in the workbooks is that you can create on-the-go ratios. So I can tick the gases that I want to compare, and Perception will automatically generate a real-time ratio calculation of those gases and display it in the chart, as you can see here. Then we have our gas ratios, which is our Juniper's and Rogers ratios comparative. So you can see I can select the IEC 60599 or the IEEE ratio, and I can also go into a table that tells you exactly what you're looking at in terms of the visualization in the cube. So these are the ratios used in those particular diagnostics, and what their formulas are, and what the condition statements and the descriptions of those conditions are. And then finally we have our key gas, which again has our statistical matching. So you can see we statistically match which of these particular conditions we feel is closest to the gas pattern that's in the multi-gas product. So you can see, for example, in here we're saying we're 84% sure that this particular device is experiencing corona partial discharge. Perception also displays transformer models. The model information is taken from our Hydron M2 product, our MO150, and our Transflux Plus product. We display the apparent power MVA model, winding hotspot temperature, insulation aging model, moisture and bubbling model, dynamic loading model, Hydron readings model, temperature model, and the transformer status model. Perception also has the built-in capability of creating customized transformer reports. The reports are a one-page summary report that is automatically generated based on the information held in Perception. The report also contains user-editable text fields at the top, the middle, and the bottom of the report, allowing you to input your own introduction, summary, and conclusion to the report. You can also embed the different diagnostic tools that are used in Perception. For example, the Duval's triangle, key gas ratios and the total dissolved combustible gas information. We also have a trend chart that's built into the report that you can highlight specific areas to highlight when a gas is increased or decreased, drawing attention to that information. The report is designed to fit on one page specifically so that it can be given to a operator or engineer's manager or higher level managers, providing a concise summary of the asset's condition or any maintenance work that may be required to improve the asset. The report can also be customized by adding the company logo and company details to the top of the report. So to summarize, we have seen how Perception Fleet is a smart, simplified and standards-based software application that provides automated fleet and transformer analytics using built-in algorithms that work straight out of the box, as well as having the flexibility to create your own custom algorithms based on your business needs and transformer unique characteristics. The application is simple and easy to understand. We use a traffic light system and color coding to provide at a glance transformer condition and fleet assessment information. It allows and empowers organizations to make critical business decisions based on the information gathered by the monitors and sensors without the need for a large investment in resources to interpret and analyze the data.